Some series to integral calculus. Some series to integral calculus in which we have started a discussion. Okay, so what is in the plate? Which sum series we will calculate, and that sum series is very famous and it should bring certainty. Okay, what we calculated when it involves logarithmic, then we go for little bit uncertainty and we go for the Taylor series and those kind of things. This is what is the possibility that we are seeing. Anyway, now we will go toward the certainty that it can be a certain equation and it is available. I'm not saying that this is the way that we can find out. It is available. Okay, what is that? 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square plus 7 square plus n square. Can we calculate this summation? 1 square plus 2 square plus 3 square plus 4 square plus n square. This is the. Now there are two ways through which we are trying to find the solution. One way is repeated addition, one way is successive approximation. Repeated addition means if I have any item and that is added many times, then it can come to integral calculus. 2 5 plus 5 2 plus 2 plus 2 plus 2 plus 2. Then someone would write it 2 into 5. That will come at 2 into x, where x is 5. 2 into x will convert into dx, or 2 I can write as function over x. Function over x equal to 2. Function over x into x, where x is 5. 2 into 5. Function over x into x, where function over x is 2 and then x. So function over x into x, function over x into dx, and limit will go from 0 to 5. 2 into 5, 2 into 5 is same as function over x into x, where x is independent component and function over x is dependent component. Function over x is 2 and x is 5. 2 into 5 is same as function over x into x, where x is independent component and it is 5. Function over x is dependent component over the x and it is 2. Fx into x, where 1 is dependent and 1 is independent, can be rewritten as fx into dx. Limit 0 to 5. 2 dx to x 0 to 5, it will result in 2 into 5 only. Means repeated summation. If I am summing up an item repeatedly, 2 plus 2 plus 2 plus 2 plus 2, 5, then 2 into 5. Okay, now can I solve it? 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square. Can I solve it through repeated addition? Okay, how many terms we have? 1 square plus 2 square plus 3 square plus 4 square plus n square. Okay, if I watch it closely, then there are n terms. Let's divide into n different parts. First part is 1 square, second part is 2 square, third part is 3 square, nth part is n square. Can I write it as same? All parts should be exactly same. Can I write in that fashion? If I want all part exactly same, then first part I can write as x square, second part x square, third part x square. Now it is repeated addition. X square plus x square plus x square plus x square plus last term is also x square. I have to add x square n times where x is variable. But on note paper I can write as x square plus x square, okay, plus x square n number of times. I can rewrite as x square into x number of times. X square into dx. Limit 0 to n because there are n items. 0 to n. X square integration is x to the power 3 by 3. 0 to n to the power 3 by 3 minus 0. N to the power 3 by 3 means The solution will be in the power of 3, but it may not be perfect. Someone would say, this doesn't look like a perfect. Okay, if I have done integration, there will be a kind of a constant there, n to the power 3 by 3 plus a constant. What is a constant that no one knows? Someone can set boundary condition. If integration has come, then someone can set boundary condition and then try whatever it is. The result is coming as n to the power 3 by 3 some plus some constant. This may be not be perfect solution. Someone will say, I have read in the book or I have deduced it through algebra and it is not n to the power 3 by 3, but I have gotten a hint that it is n to the power 3 by 3, means it is n to the power 3. This hint at least I am receiving. So this hint at least I am getting. Okay, then what can be perfect solution? Perfect solution will come through successive approximation. Successive approximation goes step by step. Successive approximation goes step by step. What is a step by step? What is the problem? Problem is sigma. Sigma means summation sign. Sigma sign summation x equal to 1 to n. Summation x equal to 1 to n function over x. This is what we are trying to calculate. Summation x equal to 1 to n function over x. What are you trying? Function over x plus function over x plus function over x plus function over x plus function over x n number of times, where x is variable and it starts from 1, means function over 1 plus function over 2 plus function over 3 plus function over 4, or function over n. Function over x at x equal to 1. What is fx? Fx is x square. At x equal to 1, it is 1 square. So 1 square plus 2 square plus 3 square plus 4 square plus n square can be rewritten as x square, can be rewritten as function over x. Summation x equal to 1 to n function over x. Summation x equal to 1 to n function over x. Okay, fx need to be added n number of times. Make sense? Now this I have to find. What is the solution? This is what I need to find. What is the solution? If I see fx function over x at x square, it looks like a continuous function x square, but actually it is not true. Function over x is a discrete function. Function over x is a discrete function. Can I solve this discrete function summation? We cannot solve it. There is no way we can solve it. We can try through some algebraic way, doing some multiplication, division here and there, then subtraction and here and there, and then finally we can settle down in the solution. But as per there is no kind of some step by step solution that you have to follow some particular step and someone would come to solution quickly. There is nothing like that. Okay, what is discrete function? Discrete function means I have x-axis. This is x-axis and this is origin. If this is origin, this is x equal to 1, x equal to 2, x equal to 3, x equal to 4, x equal to 5, x equal to 6, like so. At x equal to 1, we are starting at 1. X equal to 1, I have one vertical bar which height is 1. At x equal to 2, I have a vertical bar which height is 2 square, this much. At x equal to 3, I have a vertical bar and height is 3 square, this much. At x equal to 4, I have a vertical bar of height 4 square, this much. If I touch all the points on the top of vertical, if this is vertical, this is vertical, this is vertical, this is vertical. If I touch all the top point of the vertical, then it will draw a curve. It will draw a curve, and this equation of curve is x square. But this x square is not a continuous function. It is a discrete function, and its value lies only at x equal to whole number, starting from 1 and it goes till n. I cannot say what is the value, what is the vertical when x equal to 2.5, undefined. This is purely a discrete function. It is not a continuous line, and that is x square. how to find summation of all the vertical. This is what we want. First vertical is 1 square, 2 square, 3 square, 4 square, 5 square, 6 square. How I can find the sum of vertical? Then someone would say, why don't you do one thing? Okay, sum of vertical you are trying. What is the area between two vertical? This vertical x equal to 1 and x equal to 2. There is a area underneath it, yeah, from x equal to 1 to x equal to 2. Compute the area. This area will be fx dx from x equal to 1 to 2. That will be area underneath it. Can this area be same as this vertical line? Not possible. Not possible at all. This vertical line is one line, whereas area is this line multiplied by the width, roughly, roughly. Because at the end there is another vertical line. So area will be like this. This area cannot be same as this vertical line. Not possible. It is possible if this width is 1 and this if this width is 1 and we are trying to calculate a rectangular area. If I am trying to calculate one rectangular area and width is 1, then this height is same as rectangular area. Makes sense? But this is not rectangular area. So this height cannot be this area. Okay, let's think about another function called gx. Let's think about another function called gx, an arbitrary function, and it is a continuous function. It is not breaking anywhere. And then try calculating the area between x equal to 1 and x equal to 2. Yeah, we can calculate this area. Can this area be same as fx at x equal to 1? Yeah, possible. Okay, then tell me what is gx that you have to find. Find one gx function for which area between x equal to 1 and x equal to 2, that area, if this is gx, then area between x equal to 1 and x equal to 2, this area should be exactly same as in fx, that is x square area, height at x equal to 1. Make sense? Okay, if I find gx in that manner, what do you mean? I'm trying to say, if I have any point here as 4, then area between 4 and 5, if I take 4 and 5 vertical, then this is fx. If I take gx function and if I take any point here as x equal to 4 and x equal to 5, if I take a area strip like this and touching the gx, this area strip should be same as fx when x equal to 4. This is fx at x. This is the vertical at x equal to 4, and that is 4 square. Can this 4 square, that is the height, should be same as, exactly same as, if I take another function as gx and if I compute area between 4 and 5 and this area go and hit here, this area should be exactly same as the first pillar, that is 4 square. Yeah, then you have to find gx. Yeah, then how many sub area we are talking now? If I have x equal to 1, 2, 3, then there has to be 3 sub area, because one sub area will exactly same as fx on the left side. If the sub area belong to x equal to 1 and x equal to 2, then gx dx from x equal to 1 to 2 should be exactly same as fx at x equal to 1. Then gx dx between 2 and 3 should be same as exactly when of fx at x equal to 2. Okay, then gx dx from 3 to 4 should be exactly same as fx at x equal to 3. What are you trying to say? I am trying to say summation, sigma sign, summation x equal to 1 to n, summation x equal to 1 to n, fx that is x square, summation x equal to 1 to n, fx should be equal to limit x equal to 1 to n plus 1. Why I am saying n plus 1? If I have taken 3 vertical at x equal to 1, 2, 3, then there are 3 sub area. One is between 1 and 2, another is between 2 and 3, and another is between 3 and 4. 3 and 4 means if 3 is n, then n to n plus 1. 1 to n plus 1 will make 3 sub area. If I add all area, If I add summation limit 1 to 2 gx dx plus limit 2 to 3 gx dx plus limit 3 to 4 or n to n plus 1 gx dx, then if I have something like that, then altogether I can write the lower limit. Integration is additive, right? 1 to 2 limit plus 2 to 3 limit plus 3 to n limit plus n to n plus limit. If I do gx dx, it will become 1 to n plus 1 gx dx, because addition of all sub area will make gx dx completely, where it is going from 1 to n plus 1, whereas verticals are up to n only. If I talk about fx, that is x square, vertical is 1, 2, 3, 4, n only. But if I take about the sub area will start from 1 and it will go till n to n plus 1, one more, so that number of sub area will match the number of verticals. So that is the scenario that we are talking about. If this is the case, then can we proceed now? Yeah, you can proceed. As per mathematical induction, what is mathematical induction? Mathematical induction is try for x equal to 1, try for x equal to 2, then try for any x equal to x or x equal to n. If all satisfies your need, then that is a formula. Okay, let's try x equal to 1. Then x equal to 1 is 1 square, that is 1, equal to 1 to 2 gx dx. 1 to 2 gx dx. What gx we can keep? What gx we can keep? Here we have 1 by 2. Hope I will start with the 1 by 2 one. I'm sorry, 1 1. Fx is 1, we'll try gx as 1. Okay, then 1 dx. 1 dx, 1 dx will become x from 1 to 2, one sub area, 1 to 2, that will become 1 only. Okay, means if I take gx as 1, 1, then it satisfies. Here it is 1, here it is 1. Let's try again 2 to 3. 2 to 3 will match fx equal to 2. Fx equal to 2 means 2 square, 4. It should come as 4. Now we are trying 2 to 3, 1 dx. In that fashion, it will become x 2 to 3, 1, 1. Here we are getting 1, here getting 4. So gx cannot be 1. Gx will be something different. Anyway, let's try for any x. Any x. What is x? This is function over x. This is function over x. At any x, fx is x square. Okay, and now we are trying to calculate sub area between x and x plus 1, and that will go and hit another function gx from x to x plus 1 like this. This sub area should be exactly same as fx at x equal to x, means fx equal to integration x to x plus 1 gx dx. Okay, if someone is able to calculate it, then ball is in his side only. Okay, what is fx equal to x plus 1 gx dx? This solution is not available in any of the book. Anyone can try. This solution is absolutely not available in any of the book. Any sum series through integral calculus. We will try now. We have fx equal to gx dx. Gx equal to dfx by dx. If fx equal to gx dx, let's differentiate both sides with dx. D of fx by dx equal to gx. Gx equal to dfx by dx. What is fx? Fx is x square. At any x, the height is x square. Dx square by dx is 2x. So let's keep dx as 2x. Integration from x to x plus 1. We started with 1 to 2, 2 to 3. It did not work well. We'll try x to x plus 1, gx dx. Gx we are taking as x square. And now we will do successive approximation. So gx we are taking as differentiation of fx. And fx differentiation is 2x. Fx is x square. Fx differentiation is 2x. 2x means dx will take 2x. 2x integration is x square only. 2x square by 2x square. Okay, and now we will put a limit. If I am putting limit, there is no requirement for a constant out there. Constant will come when it is a unlimited, undefined integration. Okay, now I have limit from x to x plus 1. x square, x square, x to x plus 1. x plus 1 whole square minus x square. That will come as 2x plus 1. 2x plus 1. This side we have 2x plus 1 and this side we have x square, not match. Here order is 2. Here order x square means order is 2. Here order is 1. So whatever we have taken, well, we have taken 2x. I have to multiply 2x. We have taken 2x. Answer is coming 2x plus 1. So 2x, here it is x square. 2x, what is common? How I have to rewrite it? That 2x will become x square. That divided. X square by 2x plus 1 I am leaving now. Just focus on the first one. X square by 2x means that will come as x by 2. I have to multiply whatever I had taken with x by 2. This is called successive approximation. First we started with fx equal to gx dx. So gx equal to dfx by dx. Gx equal to dfx by dx. That is gx. Okay. Then we started with x square differentiation is 2x. 2x, if I did integration, then it is x 2x square by 2 x square. Limit x to x plus 1. Limit x to x plus 1. And in that manner, it will become x plus 1 whole square minus x square. It will come as 2x plus 1. Here it is 2x plus 1. If I leave out 1, it is 2x and here it is x square. Both should match. It is not matching by x by 2x by x by 2. I have to multiply x by 2 and try again. We started with 2x, now multiplied by x by 2, x square. We'll try with x square now. Okay, x square integration will be x to the power 3 by 3. Limit is x to x plus 1. So x plus 1 whole to the power 3 minus x to the power 3 whole by 3. Okay, x cube will go away and then it will be 3x square plus 3x plus 1 plus 1 minus x to the power 3 gone away by 3. It will become x square plus x plus 1 by 3. X square exactly match. So we have matched it. But someone will say you got extra. You got extra. Here you have x square plus x plus 1 by 3. Here you have x square. You matched x square. But x plus 1 by 3 is extra. So x is extra. If x is extra, then we will subtract it. And we can see now if I have to subtract with x so that it will come to similar point. We'll try again. We started with x square. We will write at x square minus x. We'll try again. X square minus x, x to the power 3 by 3 minus x square by 2. X to the power 3 by 3 from x to x plus 1 will come as x square, that is wanted one. So, all right, it will come as x square plus x plus 1 by 3. This is what I remember. X square plus x plus 1 by 3. Settle down. Next is minus x square by 2. Minus 1 by 2 I can keep outside. X square. Limit is x to x plus 1. X plus 1 whole square minus x square. It will come as 2x plus 1. X square will go away. 2x plus 1. Outside minus 1 by 2 is waiting. So it will become minus x minus 1 by 2. See, this side we have x plus 1 by 3. Here we have minus x minus 1 by 2. X gone. Only thing that is remaining now is, okay, first x square we had just kept it. So altogether it will become x square plus 1 by 3 minus 1 by 2. X square matching, this is coming extra. 1 by 3 minus 1 by 2. 1 by 3 minus 1 by 2 is 1 minus 1 by 6. Someone can calculate. minus 1 by 6. Now I have to add by plus 1 by 6 so that it will normalize each other. We'll try gx with x square minus x plus 1 by 6. Again, gx dx from x to x plus 1. Someone can try gx dx from x to x plus 1. If I try gx dx from x to x plus 1, what will come? Gx is x square minus x plus 1 by 6. X square will become x to the power 3 by 3 minus 2x square minus x square by 2 plus 1 by 6x from x to x plus 1. Let's settle down for x square x to the power 3 by 3. If I settle down x to the power 3 by 3, x to the power 3 by 3 minus x square by 2, then it will come as x square minus 1 by 6. This is what we saw in the last time, but we can try again. X to the power 3 by 3, that will come as x plus 1 to the power 3 minus x to the power 3 by 3. X plus 1 to the power 3 minus x to the power 3 will come as 3x square plus 3x plus 1 by 3. X square plus x plus 1 by 3. This is the first term. Minus x square by 2 minus 1 by 2 x square limit x to x plus 1, that will come as 2x plus 1 minus x minus 1 by 2. First term is x square plus x plus 1 by 3. Next term is minus x minus 1 by 2. X square will remain because we need it anyway, and plus x minus x will go away. X square plus 1 by 3 minus 1 by 2 will remain. Last is 1 by 6x, limit x to x plus 1. It will come as 1 only, 1 by 6. Net it will become x square plus 1 by 3 minus 1 by 2 plus 1 by 6. Someone can take it will become 1 by 2 plus 1, 3, 3, 0. It will become x square only. Means left hand side fx is same as right hand side gx dx from x to x plus 1. Means if I take gx as x square minus x plus 1 by 6 as a continuous function, then if I take any area, this is gx and this is fx. Fx at any x, fx is x square. At any x to x plus 1, if I take this sub area and this sub area will hit gx, then this sub area and gx is x square minus x plus 1 by 6. This sub area under gx from x to x plus 1, that is x square minus x plus 1 by 6 dx from x to x plus 1, that this sub area is exactly same as fx at x equal to x, that is x square. Exactly same. Means now we have found a continuous function for which each sub area between x to x plus 1, means that is from 1 to 2, 2 to 3, n to n plus 1. Each sub area is exactly same as fx at x equal to x. Means all the addition of all the vertical is same as addition of all the sub area. Addition of all the vertical in fx, that is x square, is same as addition of all the sub area in gx. Means sigma x equal to 1 to n fx, that is x square, equal to limit 1 to n plus 1 gx dx, or 1 to 2 gx dx plus 2 to 3 gx dx plus 3, 3 to 4 gx dx plus n to n plus 1 gx dx. Someone can write in sigma also. Sigma x to x equal to 1 to n plus 1 gx dx integration x to x plus 1 gx dx. Sigma x to x equal to 1 to n fx equal to sigma x equal to 1 to n plus 1 integration sign x to x plus 1 gx dx. Both are same. Now summation x equal to 1 to n plus 1 limit summation x equal to 1 to n plus 1, and then integration limit x up. sigma sine x equal to 1 to n plus 1, and then integration limit x to x plus 1 gx dx. This will be exactly same as 1 to 2 gx dx plus 2 to 3 gx dx plus 3 to 4 gx dx plus n to n plus 1 gx dx, and it will become limit x equal to, I'm sorry, limit 1 to n plus 1 gx dx. We'll try now. What is gx dx? Gx is x to the power x square minus x plus 1 by 6. Integration will be x to the power 3 by 3 minus x square by 2 plus 1 by 6x from 1 to n plus 1. Let's put n plus 1. If I put n plus 1, then it will become n plus 1 to the power 3 by 3. Then it will become n to the power 3 by 3 plus n square plus n plus 1 by 3. Makes sense? Minus n square by 2, then it will become minus 1 by 2, and in bracket n square plus 2n plus 1. If I break it, it will become minus n square by 2 minus n minus 1 by 2 plus 1 by 6, that will become 1 by 6x, then n plus 1, n plus up. We'll try again. X square minus x plus 1 by 6 is gx. Integration is x to the power 3 by 3 minus x square by 2 plus 1 by 6x. Okay, first we will set n square. N square will become n plus 1 whole square by 3 minus n plus 1 whole square by 2 plus 1 by 6 n plus 1 minus, then I have to keep there 1, minus 1. If I keep 1, then how much it will become? n square by 3 minus 1 by 3 minus n square by 2 plus 1 by 2 minus minus plus 1 by 6n minus 1 by 6. This is how it will become. Someone can solve it. It is very big now. I think so. Or someone can solve part by part. Let's solve first n to the power 3 by 3 from 1 to n plus 1. Okay, in that manner it will become n to the power 3 by 3 plus n square plus n plus 1 plus 1 by 3 plus 1 by 3 and minus, now I have to set everything minus, we have n to the power 3 by 3 minus 1 by 3. So at the end we have 1 by 3 and minus 1 by 3 gone. I think gone. 1 by 3 minus 1 by 3, they took it away. It becomes simple now. N to the power 3 by 3, n to the power 3 by 3 plus n square plus n. This is what will remain here. Okay, let's try now another one. N is minus n square by 2 means now I have to set n plus, now minus 1 by 2 I can keep outside, and inside the bracket n plus 1 whole square minus 1 square. N plus 1 whole square is n square plus 2n plus 1 minus 1 gone. N square plus 2n. If I take minus 1 by 2 outside, then it will become minus n square, minus n square by 2 minus n and this side n we have already. So they will go away. I'm trying my best. So now we have now n to the power 3 by 3 plus n square minus n square by 2. It will become n square by 2. N to the power 3 by 3 plus n square by 2. Next, that is what will remain now. Last one is 1 by 6 n in bracket n plus 1 minus 1 n by 6. This is what will come. N to the power 3 by 3 plus n square by 2 plus n by 6. If I take 6 as common denominator, then it will become 2n to the power 3 plus 3n square plus n. I can take n out, then it will become n, and then it will become 2n plus 2n square plus 3n plus 1. 3n I can break, I believe, into 2n plus 1. This is what I am seeing now. So 2n square plus 2n plus n plus 1. In that fashion, 2n square plus 2n, I can take out n, I can take out 2n outside. 2n n plus 1. That said, also we have n plus 1. It will become n into n plus 1 into 2n plus 1 by 6. Okay, this is the exact solution someone can try. Let's take n equal to 1. Then 1 into 1 into 2n plus 1, that is 3. 3 into n plus 1, 6. 6 by 6, 1, 1. Let's take n equal to 2. Then 2 into 2, 4 plus 1, 5. 5 into 2, 10. 2 plus 1, 3. 30 by 6, that will come as 5, and that is true. 1 square plus 2 square is 5, 1. Let's take n equal to 3. Then 3 into 2, 6 plus 1, 7. 7 into 3, 21. 3 plus 1, 4. 21 into 4. That will come as 84. 84 by 6. That will come as 118. Huh? 84 by 6. 40. 40 will come as 40. 1 square plus 2 square is 5. Plus 3 square, 14 only. Amazing, mind blowing. Okay, we will proceed on this. This is not the only. We have to actually corroborate. We have to actually verify this result by another mean also. Okay, we verified it and it works. But there is a verification through calculus only, which verifies the result. We'll proceed on it. This proof is not available in any of the book. Anyone can try. Can we find some series through integral calculus through the basic nature of integration? Can we find some series? Amazing, mind blowing, head hitting in the wall. Please do not mind supporting us, or please mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone.